Hi, dear friends. Today we'll see classification of magnetism on the basis of permeability. Already we know there are three types of main magnetic material that are diamagnetic, paramagnetic, and ferromagnetic. Today we will see what are the main or basic differences between these three magnetic materials on the basis of some properties. So first property is behavior in external magnetic field. Means when we apply the external magnetic field, what will be happen in diamagnetic, paramagnetic, and ferromagnetic material. So in the presence of external magnetic field, in diamagnetic develop a weak magnetism in opposite direction, while in paramagnetic develop a weak magnetism in same direction, while in ferromagnetic develop a strong magnetism in a same direction. Second point, alignment of magnetic dipole in external magnetic field. Means when we applied external magnetic field, what are the effect on the magnetic dipole which are present in that magnetic material. So when we observe in diamagnetic material, these magnetic dipoles are move opposite direction with peak or slightly. That means we can show in this diagram when there is no external magnetic field applied, that time the dipoles are in their positions, and when we applied external magnetic field, that time these dipoles are slightly move in opposite direction. Where in paramagnetic material, these dipoles are move in same direction, but it is weakly, means very small, it moves in the direction of magnetic field. In diagram we can see this. In third case, that is in ferromagnetic, these dipoles are moves in same direction and it is strongly, means considerably it shifted towards in the direction of external magnetic field. Then third point, response to the external magnetic field. That is when we apply external magnetic field. In diamagnetic, it's slightly repelled by the external magnetic field. Means when we applied external magnetic field, it repelled, and that repulsion is slightly, not considerable. Then in ferromagnetic, when we applied external magnetic field, the paramagnetic material are slightly attract towards external magnetic field. In third case, in ferromagnetic, the ferromagnetic materials are strongly attracted by external magnetic field. Fifth point, susceptibility. The magnetic susceptibility chi. In diamagnetic material, the chi is very small and negative. In diamagnetic material, this magnetic susceptibility is very small and negative. That is, it is less than 0. While in paramagnetic material, it is less than 1 but positive. That means it is greater than 0 and less than 1, but it is a positive number. And in ferromagnetic material, this magnetic susceptibility is very high, which is too much greater than 1. This magnetic susceptibility is very important in magnetism, because as a maximum value of magnetic susceptibility, it shows that when we apply any external magnetic field, we can convert these magnetic material, or it can acquire magnetism very quickly. Okay, so high value of magnetic this magnetic susceptibility is very essential to convert normal material into magnetic material. Next, point of difference is effect of temperature on the susceptibility. Means when we give some temperature, what will happen in diamagnetic, paramagnetic and ferromagnetic material. So we can see the sky is independent of temperature. That is, magnetic susceptibility is independent of temperature. So in diamagnetic, even we increase or decrease the temperature, there is no effect on magnetic susceptibility. Paramagnetic material, it obey the Curie law. That Curie law is Chi is inversely proportional to temperature. So as the temperature increases, the value of magnetic susceptibility decreases. So at a low temperature, we are getting more magnetic susceptibility. So at that time, we can easily convert normal material into magnetic material. While in ferromagnetic material, the susceptibility decreases with the temperature. So as temperature increases, susceptibility decreases, but it is in complex way. There is no any perfect formula or no there is hypothesis for how with the increase in temperature magnetic susceptibility decreases. Next is Curie point. This Curie point is about the temperature. Mostly it observed in ferromagnetic. Okay, just we'll see in diamagnetic there is no Curie point. In paramagnetic also there is no Curie point, but in ferromagnetic have a definite Curie point. So in these points, just in ferromagnetic material there is a Curie point. Next point is hysteresis. The hysteresis is lagging of H behind the M. That means if we apply the external magnetic field, due to that we are getting magnetism, and when we remove that magnetic field, that time the material should be decrease their magnetism or magnetization. But in some material, though we decrease the external magnetic field, some magnetization will be permanently inside that material. That is hysteresis. So in this diamagnetic material, hysteresis is not observed. Paramagnetic material also there is no hysteresis observed, but in ferromagnetic material, hysteresis is observed. Next point is retentivity is similar as hysteresis. So some magnetic properties remain with that material. That is retentivity, or you can say it is residual magnetism. So this residual is not exhibit in diamagnetic, not exhibit in paramagnetic, but in ferromagnetic it exhibit. And final point is examples of diamagnetic, paramagnetic and ferromagnetic. We can observe in diamagnetic there is bismuth, silver, copper and hydrogen. I am repeating again, diamagnetic materials are bismuth, silver, copper, hydrogen, etc. Next, paramagnetic materials are aluminum, tin, magnesium, etc. And ferromagnetic materials are iron, steel, nickel and cobalt, etc. Just we have seen these the comparison between these three materials, diamagnetic, ferromagnetic and paramagnetic, on the basis of these 3 points. Thank you.